conductance.
Electrical conductance. Okay. कुछ न्यूमेरिकल्स किए थे ये चैप्टर के? बुक लेकर आए तो फायदा तो क्वेश्चन करा देता तुम्हें। फ्रंट वाले के क्वेश्चन थोड़ा ना हो, पता नहीं मुझे याद नहीं। न्यूमेरिकल्स किए थे क्या भाई करंट इलेक्ट्रिसिटी के? क्वेश्चन नंबर 1, फाइंड द for q as a function of time 3t square plus 2t minus 1 plus 1. Find q at t equals to 0 first. Second, q at t equals to 1. Third, current I at t equals to 0. And fourth, current I at t equals to 1. So in this type of question, we have charge as a function of time, and we want to have current I as a function of time. But before that, if I want to have amount of charge at time t equals to 0, so how will you solve it? Put value of t into the expression. So this will be 3 times 0 square plus 2 times 0 plus 1. Answer will be 1 unit. And let's say unit is in coulombs. So this will be 1 coulomb. Charge q at t equals to 1 second instant will be 3 into 1 whole square 2 into 1 plus 1, which will be, I think, 6 coulomb. Then we have to find out current I as a function of time t, and current I is dq by dt. So this will be d by dt of q. Q is 3t square plus 2t plus 1. On taking time derivative, this will be 6t plus 2. Now, if we want to have current I at t equals to 0 instant, this will be 6 into 0 plus 2 unit. The answer will be 2 unit, that is 2 ampere. And we can also find out current I at t equals to 1 instant. This will be 6 into 1 plus 2, that is 8 ampere. Understood? Understood or any doubt? Yes? Okay. Next question is find the electrical conductance of a wire of length 1 meter and radius 2 millimeter. If resistivity of the material is 2 into 10 raised to power minus 5 ohm meter. So how will you solve it? First of all, what is electrical conductance? Yes? Anyone? What is electrical conductance? कोई नहीं बता रहा? सो रहे होगे भाई आप लोग? Electrical conductance is defined as reciprocal of resistance. So we write it as electrical conductance C is equals to 1 by R. So to find out electrical conductance, we have to work on resistance. And what is the resistance of a wire? Resistance R is given by rho L by A. So if you will put the value of R into the expression, this will look like 1 over rho L by A, which means conductance can be given as A divided by rho into L. If we have an electrical wire, its area will be pi R square by rho into L. What is the value of pi? Let me write it as pi. What is the value of R? Radius is 2 mm. So we have to convert it into SI system, SI unit. So 2 mm will be 2 into 10 raised to power minus 3 meter to the whole divided by value of rho is 2 into 10 raised to power minus 5 ohm meter and length is 1. So I think calculation is very simple. So we can take pi 3.14 because there is no factor of 7 into this will be 4 into 10 raised to power minus 6 divided by 2 into 10 raised to power minus 5. On simplification, this will give 2. This will be 10 raised to power minus 1. So conductance will be 2 4 ja 8, 2 1 ja 2, 2 3 ja 6.28 times 10 raised to power minus 1, that is 0.628. Because conductance is 1 by R, so its unit will be ohm inverse. Ohm inverse is also known as Moho or Simon. Are you getting it or any doubt? Okay. Question will be simple. Okay, let's do one question based on Ohm's law. Question is a conducting wire is connected with 20-volt potential. Find the current in the wire if resistance of the wire is resistance of the wire is, let's say, 2 ohm, keeping physical conditions constant. So in this case, we have potential V 20 volt, resistance are 2 ohm, and we are looking for current I. So relation is V is equals to IR and I will be V by R. So this will be 20 divided by 2, that is 10 ampere. Understood?
Yes, sir.
Next
Yes,
question
sir.
is, yes, any doubt?
No,
No, sir.
sir.
Okay. Question is, the resistance of a wire. The resistance of a wire is 10 ohm. It is stretched. It is stretched so as to reduce its diameter to half. Its diameter to half. The resistance of the wire will be now. The resistance of the wire will be now. Option A is 40 ohm. Option B is 80 ohm. Option C is 160 ohm. Option D is 320 ohm. So how will you solve it? In this case, information is given about diameter. It's not about length. If it was in length, in terms of length, we have direct result that R new will be N square times R old. But this time, information is not about length. It's about diameter. So we have to connect it with length and then we will apply the formula. And for that, we know that if you will stretch or compress a wire, its volume will be same because mass is conserved. So V old will be equals to V new, that is V1 equals to V2. And in that case, A into L, A1 L1 is equals to A2 into L2 because volume is base area into height. In this case, length of the wire will be taken as height. So you will get A1 by A2 as L2 by L1. And this relation clearly indicates that length is inversely related with area. Yes, length is inversely related with area, which indicates that if you are stretching the wire, its length will increase and its area will decrease. And interesting point is there will be relation in the there will be relation in terms of radius and diameter also. If you will look at it, it is L directly proportional 1 by A. A is cross sectional area which can be given as pi r square. And if you will convert it into diameter, this will be pi d square by 4, where d is diameter. So I will write it directly pi d square by 4. and on arranging this will be L by pi d square. I am not interested in constant, so L and pi are useless. Sorry, 4 and pi are useless. So we will work on L and D. And now the question can be D. We are stretching it such that diameter is half. So if this particular factor is half, then what will be the L factor? Because D is half, so this will be half square. That is 1/4, which means length will be 4 times. So according to this situation, we can state that R new is equals to N square into R old, where N is the new length, or the factor by which length is increased. I should write it as factor by which length is increased. So I think answer will be R new is equals to length is 4 times increased. So this will be 4 square into R old. And R new will be 16 into 10, that is 160. It will be the correct answer. So we will select option C. Understood or any doubt? Yes.
Understood, sir.
In exam, this much time will not be taken. Basically, I will not start from here in exam. If I have studied it and I know the relation between area and length, I will just start it from here, and then I will connect area with diameter. So in 2 steps, I will get the answer.
Sir, what is N here?
N is the factor by which we are increasing the length of a wire. Let's say we have a wire of length L and we stretch the wire such that its length is N times original length. Which means if I have 2 meter length wire and I stretch it to make it 6 meter, it means from 2 to 6, I am increasing the length by factor 3. So N will be 3 in this case. Are you getting it?
Yes, sir.
Okay. Now we have a new topic, which is electric cell, internal resistance, and their combinations. Okay, so let's say we have electrical cell. What is electrical cell? Yes, electrical cell is a device which converts chemical energy into electrical energy. And for any electrical cell, we define certain parameters or some simple terms, out of which first one is, first of all, let's say types of cells, types of electrical cells. there are two types of cells. Number one is known as primary cell, and number two, secondary cells. Primary cells cannot be recharged, so they are one time used, and secondary cells can be recharged, so they can be used again and again. Now, for an electric cell, we first define EMF of a cell. EMF is नहीं, उसके अंदर रिएक्शंस यूनिडायरेक्शनल होते हैं, रिवर्स डायरेक्शन में नहीं जाता. E is electromotive force. Electromotive force. Electromotive force basically is not a force. The term is a little bit confusing. Electromotive force seems like this will be a force, but it is not a force. It is basically potential. So EMF is nothing but potential, and this is the amount of energy that will be utilized to make flow of charge from one terminal of the circuit to the another terminal of the circuit. And if you want to have EMF of any electric cell, we will give it by E. That will be same as V, that is W by Q. W is the amount of work done to carry a unit charge from one terminal to another terminal, and Q is the charge that we are taking from one terminal to another terminal. It can also be defined in terms of energy, because work done is equivalent to energy, so you can also write it as E by Q. Unit for electromotive force E or EMF will be joule per coulomb, because energy will be in joules and charge is in coulombs. And joule per coulomb is also known as volt. So SI unit of EMF is same as SI unit of potential and potential difference. Dimensions will also be same. Next is terminal potential and internal resistance. So let's say we have a wire, or let's say we have a circuit in which we have some external resistance capital R, and then we have a cell with some internal resistance small r. EMF is given by E. Let me give it as by small e, because we are taking it as small e. E. So in this circuit, capital R is resistance, external resistance, while small r is internal resistance. Internal resistance means this is the resistance of cell. It is not of circuit. Resistance of cell. And E is EMF of the cell. Now E is EMF of the cell, which is overall energy of the cell. Some of the energy will be utilized against small resistance R, and the remaining energy will be utilized for capital R resistance. So there will be some potential at the terminal of capital R, and there will be some potential at the terminals of small r. The potential difference or the potential at the end points of the resistance R, capital R or external circuit, is known as terminal potential, and this is given by V. So in this case, V is terminal potential. V is terminal potential. Now let's say there is current I in the circuit. Current I in the circuit. So according to Ohm's law, how much energy will be utilized here? Because potential is a form of energy, so we can write it as V is equals to IR. And how much energy will be utilized here? This will be I into small r. Because cell is in series combination with the resistance, so there will be current I throughout the circuit, current I for capital R and current I for small r. Potential drop for capital R will be I capital R and potential drop for small r will be I into small r. Total potential or total energy of the circuit or total energy of the cell is E, and this total energy will be utilized in energy to flow charge in capital R plus energy to flow charge through small r. So E can be given as V at R plus V at small r, which means potential drop for capital R and potential drop for small r. So E will be I into capital R plus I into small r. If you take I common, this will be R plus R. This is very important relation. E is equals to I into R plus R. And from this relation, you can also find out the value of I, where E is total potential of the circuit, including capital R and small r, divided by total resistance of the circuit, that is capital R plus small r. If you are interested in small r, from this relation, we can also find out small r. This will be using the same relation. We can write it as E by I is equals to R plus R. And if you are interested in small r, this will be E by I minus R. Understood? Or the same relation can also be given in a different format, that is in terms of terminal potential. So if we have EMF E is equals to I into capital R plus I into small r, in this relation, I into capital R is known as terminal potential V. This is terminal potential V. So in place of I into capital R, we can have terminal potential capital V plus I into R. So I into R can also be given as E minus V. Current I will be E minus V by R. And vice versa, R will be E minus V by I. This is the formula for internal resistance. Understood? Understood or any doubt?
Understood, sir.
Okay. Next is combinations of cells or grouping of cells. Or combinations of cells. So in this case, we have n different cells, and these cells will be connected in series and parallel combination. To connect all the cells in a series combination, all the cells has to be connected in a single wire. So this arrangement will look like first cell with internal resistance R1, second cell with internal resistance R2, third cell with internal resistance R3, and so on. Nth cell with internal resistance Rn. So let's say its EMF is E1 internal resistance R1, its EMF is E2 internal resistance R2, E3 R3, and En Rn finally. So first question will be, if you are connecting different cells in series combination, what will be the equivalent resistance? So in this case, equivalent resistance E net will be sum of, sorry, if you are looking for equivalent potential or EMF of all of the cells together in series combination, so E net will be summation of EI. I starts from 1 to n, which implies that this will be E1 plus E2 plus E3 plus dash dash finally En. If you are looking for net internal resistance, R net in this case again will be, because this is series combination, so it will be R1 plus R2 plus R3 plus dash dash Rn, which can also be given as summation Ri. I starts from 1 to n. If you are looking for current I in the circuit, this will be E net divided by external resistance of the circuit plus R net. This is first combination, that is series. If you will connect cells into parallel combination, so now we have parallel combination. Let's say this is first cell with internal resistance R1, second cell with internal resistance R2, third cell with internal resistance R3, and so on, nth cell with internal resistance Rn. And finally, these all cells again connected to a single point. So this type of arrangement is parallel combination. Let's say this potential is because all of them are in parallel potential will be same, so this will be E, E, E and E. This will be R1, R2, R3 and R4. So E net in this case will be E net will be E, and for R equivalent we have formula 1 upon R net, that is same as we use in parallel combination of the resistors, 1 by R1 plus 1 by R2 plus 1 by R3 and so on, 1 by Rn. Understood? Understood or any doubt? Next point we have Kirchhoff's law. There are two laws according to Kirchhoff. First is junction rule, or we sometimes call it as KCL first, or charge rule. It states that the algebraic sum of all current meeting at a junction point in a closed circuit will be zero. So according to this, summation I is equals to 0, which implies that if there is a junction in a circuit and different currents are coming towards it, let's say this is I1, this is I2, this is I3 coming towards it, and there are certain current which are going away from it, let's say I4 and I5. In this case, current I coming towards the junction point will be same as current going away from junction point. So current towards junction point will be same as current away from junction point, which implies that I1 plus I2 plus I3 will be I4 plus I5. And if you will rearrange it, it can also be given as I1 plus I2 plus I3 minus I4 minus I5 equals to 0, which implies that summation I will be 0. So in any electrical circuit at any junction point, overall current will be 0. Current I is Q by T. Current I is Q by T is equals to 0. So from here, Q will be constant. I cannot write it as Q equals to 0, but I could write it as Q will be constant. Or in other words, there will be no charge accumulated at the junction point. If 1 coulomb charge is coming at the junction point, at the same instant 1 coulomb charge will be leaving from the junction point. Understood or any doubt?
Understood, sir.
In this case, there is a convention which is used. Current coming towards the junction point, let's say this is junction point. Current coming towards the junction point is taken as positive, and current going away from the junction point are taken as negative. This point is a junction point. Next we have KCL second, which is also known as loop rule or voltage rule. It states that in any closed circuit, net potential drop will be 0. Net potential drop will be 0 means net change in potential will be 0. So loop rule states that in any circuit, if there is certain potential drop at a particular region of the circuit, then at another region there must be potential rise, which means if 2 joule of energy is utilized at any resistor R, then at other part of the circuit will have extra 2 joule energy. Energy cannot be created nor be destroyed. So loop rule is nothing but another version of law of conservation of energy. So sometimes question is also in this form, on what basic principle loop rule is based. So the answer will be law of conservation of energy. And for KCL first, conservation of charge. In KCL first, it is based on conservation of charge. Understood? This topic is also completed.
Hello, sir.
Yes.
Sir, Kirchhoff's second rule is KVL now.
Kirchhoff's second rule is
KVL, Kirchhoff voltage law.
yes. KVL भी बोल
Okay, sir.
सकते हैं आप. What was the last topic in chemistry? Yes. Anyone? कोई तो बता दो भाई. किसी को भी याद नहीं है, इतने महान बच्चे हैं ये. बताओ. ये भी नहीं पता क्या ही चल रहा है टॉपिक हमारा. In last session we have completed modern periodic table and position of elements in modern periodic table, how to find out block, how to find out group number, how to find out period number. And now in this chapter, last topic is periodic properties in periodic table or trends in periodic table. So topic is trends in periodic table. Trends in periodic table. Before study of trends in periodic table, first of all we have to discuss about some definitions and terms. First one is let's say atomic radius. What is atomic radius? Atomic radius can be defined as the distance between outermost cell and center of the nucleus. Atomic radius may be defined in different way for different chemicals. For example, in case of metals, atomic radius will become metallic radius. In case of gases, it will become covalent radius. And in bonded atoms, again we call it as covalent radius. So it may be in any form, but the basic concept is atomic radius is the distance between the center of the nucleus to the outermost cell of the atom. Apart from atomic radius, we also have ionic radius. Ionic radius is the radius for ions, that is distance between the center of the nucleus to the outermost cell of any ion, whether it is positive or negative. Then we have effective nuclear charge. Effective nuclear charge, which is given by Z effective is equals to Z minus sigma. In this case, Z is atomic number of the atom and sigma is known as screening constant, which is the measurement of or quantification of screening effect. Screening effect. Screening effect is also known as shielding effect. So what is the concept of Z effective? Z effective is the net nuclear charge that will be working for the electrons in outermost cell. Why is it so that all of the nuclear charge will not be working? Because some of the nuclear charge will go against the electrons which are shielding outer electrons. Which are shielding outer electron means inner electrons of an atom try to reduce the attraction force of the nucleus to the outermost electrons. This is known as screening effect or shielding effect. So some of the charge will work against this shielding or screening. So there will be less amount of charge which will be effective for the outermost electrons. And this charge is effective nuclear charge, which is given by Z effective. And the formula is Z minus sigma. Now the question may be, which electrons will have greatest shielding effect? So remember, shielding effect will be maximum for S electrons, then P, then D, and then so S electrons give maximum possible shielding or screening. Next point is atomic radius, ionic radius, effective nuclear charge. Next point is ionization enthalpy. Ionization enthalpy. Could anyone define it? What is ionization enthalpy? Or in some book we write it as ionization energy, and sometimes we also write it as ionization potential. This is all same. Anyone? Could anyone define it?
Sir, the amount of
Yes. एक एक करके बोलो.
Sir, the minimum energy required to remove the outermost shell in a ground state from an isolated gaseous atom is known as ionization enthalpy.
परफेक्ट. ए नालायक को मोबाइल चलाने आएगा, तुम्हें रोज डेली एक ही बात समझानी पड़ेगी. पहले तो उधर से उठ के यहाँ आगे आगे बैठो. तुम बैठे ये सबसे पीछे हैं. पंचायत हो रही है यहाँ. सुनाई नहीं दिया? उधर ही आऊं मैं. आयनाइजेशन एंथैल्पी और आयनाइजेशन पोटेंशियल और आयनाइजेशन एनर्जी इज द minimum amount of energy which is required to remove one electron from the outermost shell of an isolated gaseous atom. So let's say we have any element E. Yes, वो मैं बता रहा हूँ. So we have any element T and we have its one atom. Isolated means I have to take exactly one atom, single atom, in such a way that this atom cannot interact with any other atom in the universe. It has to be alone. So first case, element is in solid phase. I will supply some amount of heat energy to it and it will be converted into liquid phase. Again, I will supply some amount of energy to it. It will be converted into gaseous phase. Now we know that in gaseous state, atoms are far from each other. This is the characteristic property of gaseous state. In gaseous state, atoms have negligible interaction or they do not interact with each other. So now we have an isolated gaseous atom, which means I have only one atom and I supply this atom certain amount of energy, IE, and by this energy, this atom will release its one electron and it will become a positive ion. So this supplied energy is known as ionization enthalpy or ionization energy. Remember, we are giving continuous energy here and here also. This energy is not counting ionization energy or ionization enthalpy. These two energies are different energy, right? So first of all, we will have atoms in gaseous phase and then we have to supply certain amount of energy which will convert it into ion by losing one electron. Understood? What should be its unit? Its unit is kilojoules per mole. After ionization enthalpy, we have which is known as electron gain enthalpy. Could anyone define it? Electron gain enthalpy. Yes. Electron gain enthalpy is the enthalpy change when an atom isolated gaseous atom gain I electron. So this is known as enthalpy change. Enthalpy change to gain an electron by an isolated gaseous atom. isolated gaseous atom. So we will write it as we have element atom of element in gaseous phase. One electron is added to it. It will become E negative in gaseous phase, and there will be certain changes in the energy. In this case, we are not saying that the energy will be released or gained. We are saying there will be certain changes in the energy because this process is both. It is exothermic as well as endothermic. In certain cases, energy may be released. In some special cases, energy may be absorbed also. So that's why we are using the word enthalpy change, and we are not clearly saying that energy will be released or absorbed. Its unit is also kilojoule per mole. Next, we have electron negativity. What is electron negativity? Yes, anyone? Electron negativity is the tendency of a bonded atom to attract bonded atom towards itself. If we have atom A and atom B, then one of the atom A or atom B, according to their strength, will try to pull these electrons towards themselves. In that case, electron will be shifted towards one of the atom. It may be either A atom or B atom, and there will be some partial positive charge at one atom and some partial negative charge on the another atom. So this tendency of bonded atoms to attract the bonded electrons towards themselves is known as electronegativity. Important point is electronegativity can be defined if and only if atoms are in bonded state. If we have atoms in isolated form, there will be no concept of electronegativity. So electronegativity is a concept which is related to bonding or covalent bond mainly, if we are going to be very precise. So this is electronegativity. Apart from this, you must remember some points also. For example, what is metallic nature? Metallic nature is tendency to lose electrons. What will be non-metallic nature? Yes, non-metallic nature will be what? Tendency
to gain electron.
to gain electron. Then we have reducing nature. What is reducing nature? Anyone? Reducing nature is again, reducing nature is same as metallic nature. So reducing agent are the agents which will reduce other compound or chemical and oxidize by themselves. So in reducing nature, oxidation number increases, electron are lost. So electron will be lost in this case. So basically reducing nature means tendency to lose electron again. So this is tendency to lose electron. Oxidizing nature will be opposite of reducing nature. So in oxidizing nature, oxidation number will be decreased, electrons will be gained, and we can state it as tendency to gain electrons. Now we are left with nature of oxides. If we have metal and it is treated with oxygen, it will form a metal oxide. So we are interested in the nature of metal oxide. So metal oxides are generally basic in nature. Basic in nature, but there are some special metals, which have amphoteric oxides. What are amphoteric oxides? Anyone? Amphoteric oxides ये आपको मालूम होना चाहिए, 10th क्लास का है. Yes. Amphoteric oxides are the oxides which give both type of nature, acidic nature as well as basic nature, which means if you are treating this oxide with base, it will behave as acid, and if you are treating it with acid, it will behave as base. So both type of nature are given by these oxides, and hence these oxides are amphoteric oxides. Examples for amphoteric oxides are zinc oxide ZnO and aluminium Al2O3. There are other oxides also, SnO, PbO. These oxides are also amphoteric, but two of them are important, ZnO and Al2O3. ZnO is zinc oxide. Apart from amphoteric oxides, metal oxides are always basic in nature. In general, in most of the cases, metal oxides are basic in nature. Next we have, if we will react a non-metal with oxygen, it will form non-metal oxide if the non-metal's reactivity is good enough to react with oxygen. So it will be non-metal oxide. And now what will be the nature of non-metal oxides? So non-metal oxides will either will be acidic in nature or they will always be neutral. They will not be basic. Non-metal oxides are not basic in nature. Non-metal oxides may be acidic in nature or neutral. Some of the example for neutral oxides are CO, carbon monoxide, NO, nitrogen monoxide, H2O, water. Water is also neutral and it is oxide of hydrogen. In acidic, we have CO2, SO2, SO3. All these oxides of non-metal are acidic in nature. Understood? Yes? Any doubt? Okay. Now we can discuss the trends. How these properties will change when we go in periodic table left to right or top to bottom. So let's say this is a rough sketch of periodic table. This is left to right in periods and top to bottom. Left to right and top to bottom. First point, if you will go left to right in a periodic table, atomic number Z will increase. As a consequence of it, Z effective will increase. And if Z effective will increase, nuclear attraction at outermost cell will be greater and atomic size will be decreased. Atomic size will be decreased. If atomic size is decreased, it will be difficult for us to release electron or to remove electron. So ionization enthalpy will be increasing in periodic table left to right. Ionization energy will be increasing. Electron gain enthalpy will also be in increasing order, because if Z effective is greater on going left to right, it means nuclear attraction at outermost cell or electron is increasing, which will try to hold the electron or which will try to accept the electron easily. So electron gain enthalpy will increase. electron negativity will also increase. Metallic nature, on going left to right, nuclear attraction is increasing, which means tendency to lose electron is decreasing. So metallic nature will be decreasing. Metallic nature will be decreasing. Metallic nature is in decreasing order. It means non-metallic nature will be in increasing order, which again implies that reducing nature left to right will decrease. Reducing nature will decrease, but oxidizing nature will increase. Oxidizing nature will increase. Understood or any doubt? Now, because non-metallic nature is increasing, it means basic nature of oxide will decrease. Basic nature of oxide will decrease, and opposite to it, acidic nature of oxide will increase. Yes. Any doubt? Yes. Any doubt? Anyone? Okay, now whatever is the trending in periods, it will be opposite in groups. So if we are going top to bottom in a group, top to bottom in a group, first point, atomic number Z increases. Second point, Z effective also increases, but number of cells also increases in group. Number of cells also increases, due to which atomic size increases. Atomic size increases. Because atomic size increasing, so it will be easy for us to remove the electron, which means ionization enthalpy will decrease. Electron gain enthalpy will also decrease. Electronegativity will also decrease. Metallic nature will increase in this case. Metallic nature increases. Metallic nature increasing means reducing nature increasing. Non-metallic nature decreases. Which means oxidizing nature is increasing. Basic oxides, basic nature of oxides will also increase because metallic nature is increasing, and acidic nature of oxides will decrease. Any doubt in it? Okay. Now tell me about the element which has highest electron gain enthalpy. Highest electron gain enthalpy must be for fluorine atom, but it is an exception, and this is for tin atom. Yes. Highest electronegativity. highest electronegativity is for fluorine.
Fluorine.
Yes, understood?
Yes, sir. Yes.
Okay. Periodic table is completed. तो 50 में कुछ क्वेश्चन कर लेते हैं, राइट?
सर्टन हाइट से उनको ड्रॉप किया हमने, तो उनका पोटेंशियल एनर्जी सेम रहेगा ना? देखो, two bodies of unequal masses are dropped from a tower at any instant. They have equal momentum, acceleration, potential energy, kinetic energy. कैसे सर? बट सर पोटेंशियल एनर्जी क्यों नहीं होगी? मैंने सिर्फ एच को कंसीडर किया। एक बराबर
मैक्सिमम साइज of the following has maximum size. Option A, Al minus. Option B, neon Ne. Option C, sodium Na plus. And option D, fluorine F minus. Which will have the greatest size or which will have the maximum size? Yes. Next question is, which of the following has maximum electronegativity? Options are Cl, Br, F, carbon. Which of the following has minimum ionization energy? Which of the following has minimum ionization energy? Options are F Cl Br I. Next question is the tendency towards complex formation is maximum in tendency to form complex is maximum in option A S block elements, option B P block elements, option C D block elements, and finally option D none of these. Yes, anyone answer? So which of the following has maximum size? Noble gases has maximum size in any period. Which of the following has maximum electronegativity? Maximum electronegativity for an atom. Which of the following has minimum ionization energy? So if we go left to right, ionization energy increases and top to bottom it decreases. So it will be minimum for the bottommost element. And in FClBri, I is the bottommost. So this will be minimum for I. Tendency to form complex compounds or coordination compounds. Complex compounds are formed by D and F both. So in this case, we have understood. बस ऐसे ही क्वेश्चन आते हैं सिंपल सिंपल मैथ्स निकाल लेंगे What was the last topic in maths?
Equivalence relation.
मैथ्स में क्या किया था भाई हमने रिलेशन किया था yes or no types of relation is completed reflexive symmetric transitive equivalence relation
Yes, sir.
Yes, sir.
okay there are some standard formula for relations first one if we have a set A with cardinal number n. Number of elements in set A is, let's say, n. The question is number of identity relation on set A. Number of identity relations. How many identity relation can be formed on set A? So there will be one and only one identity relation, because identity relation is each element has to be related with itself only. So number of identity relation will be one. What will be number of reflexive relations? Number of reflexive relations is 2 raised to power n square minus n. Number of symmetric relation. Number of symmetric relations is given by 2 raised to power n into n plus 1 by 2. And there is no specific formula for number of transitive relations, equivalence relation. You have to remember it. Let's do some question. If set A is 1, 2, 3, find number 1, number of identity relations on set A. Number 2, number of reflexive relations on set A. Number 3, number of symmetric relations on set A. So, what will be the answer for question number first? In question first, we want to have number of identity relations. There is one and only one identity relation possible on any set. Second is number of reflexive relations. Reflexive. So this is given by 2 raised to power n square minus n. So this will be 2 raised to power 3 square minus 3. 9 minus 3 is 6. 2 raised to power 6 is 64. Third is number of symmetric relations. So this is given by 2 raised to power n into n plus 1 by 2. N is 3. So this will be 3 into 3 plus 1. 3 into 4 by 2. That will be again 2 raised to 6. 64 answer. Understood? Next question is, let's say set A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there is a relation R which is defined from set A to set A such that R is equals to X, Y, such that Y is equals to 2X. Where X and Y are coming from set A, Y equals to 2X, X, Y belongs to set A. So you have to find relation R in roster form or tabular form, and hence find domain of this relation R and also find range of this relation R. So what do you think? What will be relation R? Relation R, we have X, Y, depend only if Y is equals to twice of X. It means for a specific value of X, we have a specific value of Y. and x can be taken from set A only. You cannot take any value of x, and y has to be in set A. So let's say if I take x1, this will be 2. So first element is 1 comma 2. If we take x2, this will be 4. If we take x3, this will be 6. And 4 comma 8 will be there. 4, 5 comma 10 will be there. After 5, we have 6. And if you will take 6, y will be 12. And 12 is not in set A, which means you cannot relate element 6 with any element of set A, which means this will be the only relation R. We cannot go further for 6, 7, 8, and so on. So this is relation R in roster form. Now we can find out its domain. Domain of relation R is the first element of ordered pair. So this will be 1, comma 2, comma 3, comma 4, comma 5. What will be range for relation R? Range is the second element. 2, 4, 6, 8, 10. Understood? So if I want to know the nature of relation R, is relation R identity? Yes. Does the given relation R will be identity relation? Yes or no? Is relation R identity? Yes or no? Yes. This one. Is it identity? Yes or no? नहीं लग रहा नहीं क्या होता है नहीं होगा it's not identity because elements of set A are not connected with itself. Is it reflexive? No. Is it symmetric? Now if you will look for symmetry, it is 1 comma 2 and there is no element like 2 comma 1, so it's not symmetric either. Is it transitive? For transitive, let's say we have 1 comma 2 and 2 comma 4, so we must have 1 comma 4. 1 comma 4 is not in relation R, so it is not transitive also. Understood? Yes, or any doubt? Next question is सही नहीं इसमें तो हो गया नहीं गड़बड़ चैप्टर ही नहीं दे रखा है इसमें चलो नेक्स्ट क्वेश्चन इज let's say set B is the set of all lines in a plane. All lines in a plane. And there is a relation R which is defined from set B to set B such that if we take two lines L1 and L2, they will be in relation R if and only if line L1 is parallel to line L2. Check whether the given relation is reflexive, symmetric, and transitive. Check for reflexivity, symmetry, and transitivity. How will you solve it? So, first of all, we will check reflectivity. For reflectivity, we have to check whether all elements of set V are connected with itself or not. And set V is set of lines, so we have to check whether line L is connected to itself according to the given condition. The condition is two lines will be in relation R if they are parallel. So if I take a line L, is line L parallel to itself? Or in other words, is any line parallel to itself? Yes or no? ये 8th 9th का है भाई, ये पता होना चाहिए आप लोगों को. Is any line parallel to itself? Yes or no? Euclid's geometry. कुछ फायदा नहीं है, मैं ही लिख देता हूँ, गरीब लोग हैं. Each line is parallel to itself. Each line is parallel to itself, which means line L will be connected to itself. L comma L will be in relation R, which means given relation is reflexive. Now, for symmetric, if line L1 is parallel to line L2, then if line L1 is parallel to line L2, then line L2 will also be parallel to line L1. Yes or no? So if line L1 is parallel to line L2, L2 will also be parallel to L1, which means L1 comma L2 in relation R, then L2 comma L1 will also be in relation R. So for each ordered pair, there will be some symmetric ordered pair. Like for L1 comma L2, we have L2. For L3 comma L4, we will have L4 comma L3, which implies that given relation is symmetric also. Now we will look for transitivity. For transitivity. In transitivity, let's say we have L1 comma L2 belongs to R and L2 comma L3 is also in relation R. So we have to check for L1 and L3 relation. Will L1 and L3 will be in relation R or not? Since L1 comma L2 belongs to R, it implies that line L1 is parallel to line L2. And L2 comma L3 also belongs to R, which implies that L2 is parallel to L3. Since L1 is parallel to L2 and L2 is parallel, therefore L1 will also be parallel to L3, which implies that L1 comma L3 will also be in relation R, which indicates that given relation is transitive also. So given relation R is reflexive, symmetric, and transitive also, which implies that relation R can be considered as तो सही नहीं होगा, हम बोलना चाहिए relation R is Equivalence relation. Equivalence relation. Because equivalence relation is a relation which is reflexive, symmetric, and transitive. In this case, relation R is reflexive, symmetric, and transitive. Therefore, it will be equivalence relation. Any doubt? Yes. Any doubt? Okay. Now we can define a function. After relation, we have function. What is a function? Could anyone define it? A function is a special type of relation. What is special in it? What is the condition that will make it a function? Or what are the criteria for which a relation will be a function? So function is a special type of relation, a relation in which each element in domain must have one and only one image. So if you will take any element from domain, then it must have one and only one image. So there are 2 points in this statement. First point is each element of domain has to be related with someone. And second point is each element of the domain can have one and only one image. In other words, a single element of domain cannot have more than one image. So it has to be connected with one and only one element in codomain. This is a function. In some book, we write it as function as a machine. Function is a machine, which means it is a machine in which certain input will be given. Certain input will be given, and function will process on these inputs and will give certain output. So function is a input output. In mathematics, input is generally given by variable x and output is generally taken as y. So we symbolically represent it as f is equals y is equals to f of x. Means y is a function of x. The value of y depends on the value of x. If you will put certain value of x, accordingly we will get the value of y. And for a specific value of x, there will be a specific value of y. So function is also can be considered a machine. Next is if we have a function defined on set A to set B, let's say we have set A and set B, and a function f is defined from set A to set B. In that case, complete set A is known as domain of function f. Complete set B is codomain for function f. Codomain may be or may not be equals to range of the function. But this is clear to us that range of function f will definitely be a subset of codomain. So range is always codomain of a function. Range can be taken as codomain. Range is a subset of codomain. If we plot it in arrow diagram, it will be like this. This is set A, this is set B. The function is defined from set A to set B. Let's say here we have element A, B, C, D, E. Here we have element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now A is related with 1, B is related with 2, C is with 3, D is with 4, E is with 5. You cannot leave any element without image. We have to make image of every element in domain set A. Now, according to this question, domain of function f will be A, comma B, comma C, comma D, comma E, which is complete set A. Codomain of function f will be complete set B. But we are interested in range of function f. So in this case, range of function f will be the elements which are connected with elements in set A. So this will be 1, 2, 3, 4, 5. This is range of function f. In this, sometimes we write it as since A is connected with 1, A is related with 1. So it is also given as A related with 1, and it is also given as 1 is image of A, 1 is the image of element A, and A is the pre-image of element 1. Pre-image of element 1. Now, could you tell me what is the image of C element? What is the image of C element in this arrow diagram? Since C is connected with 3, so image of C element will be 3. And if I ask what is the pre-image of element 5, so pre-image of element 5 will be E. So this type of question may be there. Image of element C and pre-image of 5. So what is the image of C in this case? 3. And what is the pre-image of 5? That is E. Understood? Understood?
Yes, sir.
Okay. Now there is another meaning for set A. For a set y equals to f of x, a function y equals to f of x can also be represented on Cartesian plane. This is Cartesian plane, and this is x-axis and this is y-axis. On Cartesian plane, x-axis can work as domain and y-axis can work as codomain. This will be codomain and this will be domain. Let's say we take input these elements only. So elements of x-axis which are taken in function for the input are known as domain. X-axis will always represent input behavior, and y on the other side will be output. Axis बोल सकते हैं. Now on input axis, if we input certain possible values in the functions, these possible values are known as domain. And according to these possible input values, we will have certain output values, and these output values will be known as range. So these values will be range. In this point, what I am trying to say is that a function can also be given in the form of graph, or it may be a plot on x-axis and y-axis. If is it the case, then x-axis will give input and y-axis will give output, which means domain points will be on x-axis and range points will be on y-axis. Complete y-axis can also be considered as codomain. Understood? Understood? Okay. For the graphical plotation, we have horizontal line test, which will tell us whether the given graph or curve is a function or an equation. So this is HLT, and this is known as what? This is known as, one second, it's not HLT, it's VLT. VLT. That is vertical line test. So in this case, if we are given with a graph or any curve on 2D plane, we will draw a vertical line and we will look whether the vertical line cut the graph at one point or more than one point. If it cuts at exactly one point, then the given curve represents a function, and if it cuts at more than one point, then it will not represent a function. Let's take some example to understand it. Let's say we have certain curves like this. This is x-axis, y-axis. This is a curve. This is a curve. This is a curve. This is a curve. This is also a curve. If we take this curve, if we take this curve, then which curve will represent function and which curve is not function? We have to check it by VLT test. So let's say for first curve, if we will plot a straight line vertical at different points on the curve, you will notice that one line cuts the curve at one and only one point. If it is cutting the curve at exactly one point, this will be function. This is relation also and function also. Remember, every function is always a relation. Every function is always a relation, but converse is not true. Any relation may or may not be function, we cannot guarantee it. But if there is a relation, it will be guaranteed a function. Sorry, a relation. A function will always be a relation, but converse is not true. In second case, if you will draw a vertical line, you will notice that it will cut the curve at 2 points, which implies that for input x, we have two possible outputs, y1 and y2, which means if you will go by arrow diagram, here we have x and here we have y1 and y2, and one single element of domain is related with two elements in codomain, or a single element in domain has two images, which is not the condition for function. So this curve is a relation. This curve is a relation, but it is not a function. Why is it not a function? Because vertical line is cutting the curve more than one point, which indicates that in this case, one input will give more than two output. And if it is so, it cannot be a function. Function will be if and only if we have one element connected with one and only one element in codomain. What about this curve? This curve again, vertical line intersects this curve at more than one point. So this is a relation, but this is not a function. In this case, again, same condition. This is a relation, but it's not a function. This is again a condition. In this also, this is a relation but not a function. In this case, if you will draw vertical line, it will cut the curve at exactly 1 point. So this is a relation as well as a function. In this case also, the vertical line will cut the curve at exactly 1 point. So this is also relation as well as function. This also indicates that in conic sections we have parabola, hyperbola, ellipse and circle. All these are equations. All these are relations between x and y coordinate, but these are not functions. If we take a graph like this, will it be a relation? Yes, always a relation. Will it be a function? So we will plot vertical lines and you will notice that they cut at exactly 1 point. So this will also be a understood or any doubt? फंक्शन नहीं है, रिलेशन हो गई, रिलेशन होता ही है बिकॉज फंक्शन इज ए स्पेशल केस ऑफ रिलेशन. फंक्शन होने से पहले वो रिलेशन ही था. नेक्स्ट पॉइंट इज टाइप्स ऑफ फंक्शन. There are certain types of functions. Number one is one and many one. And second family is onto and into. To understand, let's say we have a function f defined from set A to set B. What do we mean by 1, 1? 1, 1 function. 1, 1 function means one element of set B is connected with only one element of set A, which means any element in set B cannot have pre-imaged. In other words, you can also state it as each element of set B, sorry, it's not each element, it must be any element of set B must have only one pre-image. Only one pre-image. Or it can also be stated as two elements of set B, sorry, two elements of set A cannot have, two elements of set A cannot have one image. So this type of function will be 1, 1. For example, let's say this is set A, this is set B, 1, 2, 3, 4, A, B, C, D, E. 1 is related with A, 2 is related with B, 3 is related with C, and 4 is related with D. So you will notice that any element in set B has only one pre-image. So element of set B can have only one pre-image. It means the function will be 1, 1. Or in another words, any two elements of set A cannot have one image. If one is connected to A, two cannot be connected with A. So one element from set A is connected with one element from set B. That's why we are naming it as 1, 1. Next we have many one. Many one means more than one element of set A can have one preimage. In this case, more than one element, 1, 2, 3, 4, A, B, C, D. In this case, 1 is connected to A, 2 is also connected to A, 3 is connected to B, 4 is also connected to B. So in this type of relation, more than one element of set A or more than one element of domain will have one preimage. That's why we are calling it as many. Many one. Many one means many elements from domain are connected with one element from codomain. So that's why this is known as many one. Then we have onto. Onto function is a function in which range will be exactly same as codomain, which means no element of codomain, no element of codomain can exist without preimage. Without preimage, which means each element of codomain will have at least one preimage. ज्यादा से ज्यादा कितने भी हो उसका मसला है नहीं. But if we are having 3 elements in codomain, then all the 3 elements must have at least one preimage. And if this is the case, in that case, range of the function and codomain of the function will be exactly same. So if range is equals to codomain, the function will be onto. Into function is a function for which range is not equals to codomain. Range is not equals to codomain means at least one element in codomain, at least one element is such that it has no preimage. It has no preimage. At least एक element ऐसा जरूर हो जिसका preimage ना हो. In that case, it will be into. For example, set A, set B, 1, 2, 3, 4, A, B, set A and set B, 1, 2, 3, 4, A, B, C, D, E. 1 is connected with 2, 2 is connected with 3 and 4. You will notice that all the elements in set B are having preimage. So this will be on 2. In this case, 1 is connected to A, 2 is connected to A, 3 is connected to B, and 4 is connected to C. In this case, 2 elements in codomain are such that they have no preimage. So this will be into. If you are going for many one, 1, 1, this will be many one. Because many elements of domain are connected to one element of codomain. Many one. This will also be many one. Because many elements, that is 1 and 2, are connected with one element A of the codomain. So this is many one onto, this is many one into. There may be different permutations and combinations of 1 many one and onto into. So functions may also be categorized as 1 onto, 1 into, then many one onto and many one into. So you have to remember the core point about 1 and many one onto and into. 1 is also known as injective. 1 function is also known as injective function, and onto function is also known as surjective function. Surjective. Understood? Understood or any doubt?
बच्चों के भविष्य बहुत खतरनाक होते हैं अगर कुछ चेक किया तो ये दस बार बदल दिया इसका।
नहीं होना चाहिए। Yes? कौन से वाला? Manual. Manual is a type of function in which many elements from domain will be connected to one element in codomain. मतलब इधर के बहुत सारे एलिमेंट एक इमेज वहां एक इमेज तो वो मैनी वन मैनी वन इधर के बहुत सारे इधर के एक के साथ कनेक्टेड ऐसे याद रखो। और अगर मैनी वन नहीं है तो फिर डेफिनेटली वन वन ही होगा। Okay, now we can have a topic from general aptitude. जनरल एप्टीट्यूड में आज क्या पढ़ेंगे? इंटरेस्ट करा दिया था ना, कंपाउंड एंड सिंपल इंटरेस्ट। यस, कंपाउंड एंड सिंपल इंटरेस्ट।
Yes, sir.
Okay, so now we can have okay. A concept similar to time and work. This is known as Pipes and systems. In this, we have a pipe connected to a tank which will input water into the tank. This is known as inlet. And there is another pipe connected to the same tank which will empty the tank. This is known as outlet. बोलो ना सर, ऊपर हूँ, मैं लेक्चर ले रहा हूँ. 10:20 10:20 बोलो. 6 बजे आ जाता है डाल दो. अरे पक्का आ जाऊंगा भाई, तेरे लिए जान आ जाएगा. कैसी बात कर रहे हैं. Pipes and systems. So there will be two pipes connected to a single tank. One pipe for input the water and one pipe for to let out the water. One is known as inlet and another one is known as outlet. And the rate of putting water in will be different as taking it out. So the question will be something like this: if we are running two pipes together, how much part of the tank will be filled? If one pipe is putting water into the tank and another pipe is taking it out, so what part of the tank will be filled up? So first is inlet pipe and second is outlet. And both of them have different speed, different rate. Inlet is the pipe which is used to put water into the tank, and outlet is the pipe which will use to empty the tank. So we can simply write it here: to fill the tank, and this is to empty the tank. Concept will be same as we were doing in time and work. We will convert it into 1 unit time and then we will simplify the question. Okay. First point is if a pipe can fill a tank in X hours, then what part of the tank will be filled in 1 hour? So first point is if a pipe can fill a tank in X hours, then part filled in 1 hour will be 1 pipe. It's a simple calculation. If X hours is taking to complete work 1 unit will give 1 by X. Second point is if a pipe can empty a full tank in Y hours, then part emptied in 1 hour will be 1 by Y. It is again same. Y hours to empty full tank. So for 1 hour it will be 1 by Y. Next is if both of them are working together. If both inlet and outlet are working together, are working together. Then are working together. Then net part which is filled. Net part filled in 1 hour. So this will be part of the tank filled in 1 hour, that is 1 by x, minus part of the tank which is emptied, that is 1 by y. So answer will be 1 by x minus 1 by y. And if these two pipes are working together for, let's say, t number of hours, then what will be the net part of tank filled? Net part filled in t number of hours. So this will be part of the tank filled in 1 hour multiply number of hours. Understood or any doubt?
Understand, sir.
Yes.
No doubt, sir.
Okay. Now in this case, you have to remember that rate of inflow of water has to be greater than rate of outflow of water. Are you getting it? Because if rate of outflow is greater than the inflow, then no water will be in the tank. Like 1 मीटर पर सेकंड इन जाने का रेट है, 2 मीटर पर सेकंड बाहर आने को, तो कभी भरेगा ही नहीं, वो खाली रहेगा हमेशा. So in this case, rate of inflow will be greater than rate of outflow. Yes or no? Yes or no?
Yes, sir.
Okay. Now if you want to look for net part empty, because this is a net part filled, what will be net part emptied in 1 hour? So this will be 1 by y minus 1 by x. Let us consider an example. A tank 9 feet by 5 feet by 2 feet. So there is a tank which has a dimension 9 feet by, dimensions of the tank is 9 feet by 5 feet by 2, which means the tank is cuboidal. What will be its volume? 9 into 5 into 2, 90 cubic feet. Right? Yes or no? Okay. This will be 90 cubic feet. Now the question is, this tank is fitted with an inlet pipe and an outlet pipe. The inlet pipe pours in 576 cubic inch of water per minute. So this is information about inlet pipe. 576 cubic inch per minute is going into the tank, and the outlet pipe can empty the tank in 3 hours. So outlet pipe can empty the tank in 3 hours completely. Question is, if the tank is full and both pipes are open, both pipes are working, inlet and outlet, how many hours will it take to empty it? How many hours will it take to empty it? So first of all, we will find the rate. For inlet pipe, rate is 576 cubic inch per minute, which means in 1 minute it can fill 576 cubic inch of the tank. Cubic inch of the tank. Now what about outlet pipe? Outlet pipe can empty it in 3 hours. So let's check the rate of emptying the tank. So this will be 90 feet cube. But we are having here readings in inch, so we have to convert it into inch. 1 feet is 12 inch. So this will be 12 into 12 into 12 because it is feet cube divided by 3 hours. But again, here time is in minutes, so it has to be in minutes. So 1 hour contains 60 minutes. So if we will solve it, this will be 4, this will be 2, and on simplification it will give 864 cubic inch. So in this case, you will notice that rate for input is less and rate for output is greater, which means the tank can be emptied. If the case is reverse, in which inlet pipe has greater speed than outlet pipe, the tank can never be emptied. But in this case, tank can be emptied, and we want to know in how much time it can be emptied. So first of all, we will know net volume drain. Net volume drain in 1 minute if both the pipes are open. If both the pipes are open, then 864 will be out and 566 will be in. So net out will be 288 cubic inch per minute. And I want to empty the tank. So how much time it will take? You can consider it as 288 cubic inch can be emptied in 1 minute. So for 1 minute it will be how much? 1 by 288. Sorry, for 1 cubic inch it will be 1 by 288. And for total volume we have 90 feet cube. So for that it will be 90 into 12 into 12 into 12 because other readings are in inch divided by 280. This will be in minutes. If you will divide it by 60, the answer will be in hours. So if you will solve it, this will cancel out. This will be 3 3 is 9, 3 2 is 6, 2 6 is 12. 3 into 12 into 12 into 6 divided by 288. So 288 will be divided by 3. This will be how much? 96. And this will be again divided by 3. This will be 3 3 is 9, 3 2 is 6, 3 2 is 6. This will be 60. It will be 12 into 12 by 16. 144 by 16 means this will be 9. So total 9 hours will be taken to empty the tank completely. Understood or any doubt in it? Yes. Anyone? Any doubt? Okay, next question we have. Pipe A can fill a tank in 30 hours. Pipe A can fill a tank in 30 hours. Means in 30 hours, it will complete the tank. Pipe B can fill tank in 45 hours. So in 45 hours, tank B can complete the tank. If both pipes are opened in an empty tank, how much time will they take to fill it? So it's straightforward. For pipe A, 30 hours are taken to fill 1 unit. So 1 hour, it will be 1 by 30. For pipe B, for 1 hour, it will be 1 by 45. So net filled in 1 hour is 1 by 30 plus 1 by 45. If we will solve it, 1 by 30 plus 1 by 45, this will be 1 by let's say, let me write it as multiply and divided by 3. So this will be 3 by 90 plus 2 by 90. And overall will be 5 by 90. That is 1 by 80. So next part filled in 1 hour is 5 by 90. That is 1 by 80. So 1 by 18 part is filled in 1 hour. One part will be filled in 18 hours. You just have to reciprocate it. This concept is exactly same as time and work. Any doubt in it?
Sir, can you explain the fraction again?
Which one?
Sir, that 1 by 30 plus 1 by 45.
1 by pipe is taking 30 hours to fill tank. So in 1 hour, it will do 1 by 30 work. Similarly, pipe B will complete 1 by 45 part of the tank in 1 hour. If we will open both the pipe together, so net part of the tank that will be filled in 1 hour will be a part filled by the tank pipe A plus part filled by the pipe B. That is 130 plus 1 by 30 plus 1 by 45. So to make denominator same, I have multiplied 3 in 1 by 30 and 2 in 1 by 45. So this will be 3 by 90 plus 2 by 90, which will be 5 by 90. So net part of the tank that is filled in 1 hour is 5 by 90, which will give us 1 by 18. And if you want to know the complete time time taken to fill it completely, reciprocate the quantity which you obtained in 1 hour. So in 1 hour we are having 1 by 18. So to completely fill it, we have to take 18 hours. Understood or any doubt?
Yes, sir, I understood.
Next question is, a pipe can empty a tank in 40 minutes. To empty, it takes 40 minutes. A second pipe with diameter twice as much as that of first is also attached with the tank to empty it. How much time will the two pipes together take to empty the tank? Interesting question. So this is one pipe with its diameter D. And this pipe is taking 40 minutes to empty. Then there is another pipe which is also connected to the same tank. But this pipe has diameter double of original pipe or the first pipe, that is 2D. And the question is, if both the pipes work together how much time they will take to empty it. So now in this case, first of all, you have to check what is the relation between time and diameter. Now, time is connected with volume. If we are saying that 40 centimeter cube is dropped out in 1 minute, it means time is connected with volume, and volume is area into height, which is pi r square into height or pi d square by 4 into height. Yes or no? So you can clearly state that there is a connection between time and diameter. What is the relation between time and diameter? If diameter of the pipe will increase, it will contain more water or more liquid, and more liquid can be taken out in less time. So we can say that if we are having a smaller pipe and a bigger pipe, obviously bigger pipe will take less time to empty the tank, which clearly states that time is inversely related with size of the pipe, that is diameter. Understood or any doubt? Yes.
Understood, sir.
Okay. Okay. Now let's say time taken by, let me give it as A and it as B. Time taken by A pipe can be given as K by D square, which is 40 minutes. Proportionality sign is removed by using K. What will be the TB? TB will be K upon 2D whole square, right? So this will be 1 by 4 into K by D square. The value of K by D square is 40, so this will be 10. This will be 10. 1 by 4 into 40 will be 10 minutes. Now the question is in basic concept that we have a pipe A which can empty tank into 40 minutes, and we have a pipe B which can empty the same tank in 10 minutes. So how much time they will take together to empty it? So convert it into 1 minute. Part of the tank that will be emptied by A in 1 minute will be 1 by 40 plus part of the tank that will be emptied by pipe B in pipe B will be 1 by 10 together. So this will be 1 by 40 plus 4 by 40, that is 5 by 40, that is 1 by 8. So together A and B can empty 1 by 8 part of the tank in 1 minute. So 1 by 8 part in 1 minute, one part will be in 1 by 1 by 8, that is 8. So if both the pipe are working together, they will take 8 minutes to empty the tank. Understood? Or any doubt? Okay. कर लेंगे इस टाइप के क्वेश्चन, सिंपल सिंपल से क्वेश्चन आते हैं. Let's say a cistern has two taps which fill it in 12 minutes and 15 minutes respectively. There is also a waste pipe in the cistern. When all the three are opened, the empty cistern is full in 20 minutes. How long will the waste pipe take to empty the full cistern? Interesting question. The question is a cistern is connected with two pipes which can fill it in 12 minutes and 15 minutes respectively. Let me write it as hello. हेलो जी, हम बोलो ना। नहीं आ सकता, अभी लेक्चर चल रहा है। 20 मिनट तक, 10 10 मिनट। हम्म, हाँ हाँ बोलो। So there are two pipes. Let's say this is pipe A, this is pipe B, and there is outlet pipe C. Pipe A can fill it in 12 minutes. Pipe B can fill it in 15 minutes. And we want to know how much time pipe C will take to empty it. We do not know about pipe C. But we know that if we operate all the three pipes together, the tank can be emptied in 20 minutes. Which means if you will convert it into 1 minute, the question will be like this. By pipe A, tank will be filled 1 by 12. By pipe B, it will be filled 1 by 15. It is emptied by pipe C only. And it can empty it into 20 minutes. So it will take 1 by 20 time. If it can empty it into 20 minutes, a full tank can be emptied into 20 minutes. It means in 1 minute, it is emptying 1 by 20th part. So this will be 1 by 20 minus 1 by 12 plus 1 by 12 because this is in and this is out. So net emptied part of the tank will be this one. So if you will simplify it, this will be how much? 1 by 20. This will be 1 by 20 minus 1 by 12 minus 1 by 15. 1 by 20 minus 1 by 15 minus 1 by 12. If you will multiply by 3, this will be 3 by 60, this will be 4 by 60, and this will be minus 1 by 12. So this will be minus 1 by 60 minus 1 by 60 and minus 1 by 12 multiplied by 5 minus 1 by 60 minus 5 by 60. So this will be minus 6 by 60. This will be 1 by 10 with minus sign. Indicating that tank is empty. So it implies that pipe C in 1 minute can empty 1 by 10 part of the tank. So if only pipe C is working, it will take how much time? So 1/10 is done in 1 minute. So 1 unit will be done in 1 by 1 by 10, that is 10 minutes. So answer will be 10 minutes. Understood?
Yes, sir.
पीडीएफ भेजता हूँ भाई, ये डाउनलोड कर लेना से। अप्रैल 14 14th of April 2025. जा रहा हूँ भाई, जा रहा हूँ मैं। चेक करो भाई, जूम मीटिंग में आया है, पीडीएफ डाउनलोड कर लेंगे। डाउनलोड करके बताओ मुझे कर लिया कि नहीं।
कर लिया सर।
कोई डाउट है भाई किसी को यहाँ तक के टॉपिक में, कोई कॉन्सेप्ट पूछना हो?